So let's get started. This lesson is all about understanding our data. So we are going to be working with this MNIST data set, right, which is our data set of handwritten digits, and we want our neural network to be able to identify these digits, right? So the easiest way to download this data set is using a library called TensorFlow, which is kind of like an alternative to Pytorch. We're just going to be using it to download the data, okay? And the way I do that is it's already installed in Google Colab, so I can just press Shift Return, and you can see this is the main thing, this keras.datasets.mnist.load data, and this downloads data from the internet for you, and it downloads both what's called like training data and test data. We'll talk about this test data in the next lesson. For right now, we can just focus in on the training data. So what is that training data? If you look at, I guess, the shape, if I can type, it is 60,000 different observations, each that is a 28 by 28 grid. Let's select out the first observation and take a look at it. So we'll call this our first image. And I can plot it using matplotlib. So this is, just a kind of a popular plotting library, and we can do plt.imshow, I think, and let's actually directly put this in here. So I'm selecting the first image right from my data, or the first observation. Let's plot it. There it is, the number 5. We go to the second image. There it is, number 0, and so on, right? And this works because, remember, xtrain, this is like a list of images, each of 28 by 28. So if you select out, let's not use imshow, but let's just see what this thing is. If we select an image, remember I told you that we can kind of represent an image by, this is a grayscale image simply by, the values. So it looks like all the dark values, these are zeros. And then when it lights up, now we're getting into maybe some lighter values. All right? So that's how we represent an image. It's just, this 28 by 28 matrix of values. Now, to pass this data into our neural network, we need to do a couple of things. So the first thing we need to do is make sure our data is a tensor. Before I do that, so this was our training data, all right, xtrain. Or if we look at what's ytrain, remember, if this is like the list of features. If you want to go back to like the breast cancer data set, right? This is like the mean concavity and all that stuff. What's this y data? Let's look at the first 5. Ytrain, sorry. Well, these are the answers. These are the labels. So with our breast cancer data set, it was like, is it cancerous or not? And it gave us a 1 or a 0. Here, it's like, the first number is 5. These are all the features. And here's the correct answer for the second value, this 0. And here's the correct answer. So that's what the ytrain is the target or the labels of the data set. Okay, so we need to coerce or manipulate our data before we can feed it into a neural network. So the issue is that if you look at this data, we call type on it. We say what type is this data? It is a NumPy array. And you may remember that we cannot feed a NumPy array into a neural network. You have to feed a tensor. So let's do import torch, because I don't think we've used that before in this collab. And do torch.tensor. Do that, and let's call this my x tensor. And now if I call type of x tensor, we see it is in fact a tensor. Great. I say make sure it's the correct type because if we look at this x tensor, we're still not done. If I look at the d type, this is an integer, and we want this to be of type float. So let's call this x tensor float, I guess. I think that's fine. And remember, how do we convert it to a float? Just by doing that. And now let's take a look at the d-type again. And we see that we are now working with a float. So that's great. The next things we need to do is worry about, I suppose, the shape of the data. You know what? I know I'm going to confuse myself. I'm going to change this to be x tensor. And now, if I look at x tensor, right, where that? Okay. So x tensor is now of type float. Okay, let's keep going. If you look at the shape of the data, you see you have 60,000 records, each in this 28 by 28 grid. But that's not the format we want, because remember, what we'll do with the neural network is we want to pass through an entire vector, and we want to pass through a vector that's of length 28 times by 28 or 784. So we want, one long list of data, and currently we have, that each thing is a grid. Okay, we want to convert it into one long list. So how do we do that? Oh, and just to hammer that point home, right, the matrix algebra kind of tells us that, right? We want to get, we want to take these inner dimensions, align, and then we'll get back in this first layer 64 outputs, but a single row, right? A single row of 64 outputs to then pass to the next layer. So per observation, we're going to get like a single row. Okay, so we want to convert this into, from this 28 by 28 grid into a vector so that we can, apply this vector matrix multiplication that we know and love. So how do we convert this? And the idea is essentially to take this grid and like unspool it. So it's like one, kind of connect this second row here with this first row so that we just get one long, enormous row. Okay. So to do something like that, one way, if we start here, I'll show you. We'll call this our first image. We'll do first image.shape. Is 28 by 28. And one way we can change it is we want this to be whatever 28 times 28 is. I always forget. Sorry about that. It's 784. Okay, and we can do that by calling the view function and passing through 784. So watch this. So before it was 28 by 28. Now we're saying let's make this just one dimension. And if you call this view function, you see this? We have used the view function. Let's call this reshaped image. Okay? We have used the view function to change our 28 by 28 down to a single vector. If you look, this is just one long vector. We can make this as, even longer, still just one long vector. So we've like kind of unspooled it, right, into that one long vector, which now we can apply that matrix vector multiplication to that we know and love. All right. We should go a little bit more into this view function. Let's just explain this, see a little bit more about this view function. Okay, so the first point I want to make about this view function, let's do it down here, is that Pytorch does the math. So what does that mean? If you look at the shape, this is kind of the original image before we turn it into a vector. So it's this 28 by 28. And if you try to then convert it to, say, a single vector of length 783, Pytorch will say, hey, that is missing something, right? We cannot take 2 dimensions square of that length, of 784 pixels and convert it down to 783 pixels. That doesn't make sense. 783 is invalid for input size of 784. Okay, so this is kind of nice that it checks for us. What's even nicer is that if you say want to go from this shape of 28 by 28, and then just say, hey, let's go down from 2 dimensions. Remember, we kind of have this grid down to 1 dimension. One way to do that is to specify 1 dimension of 1 vector of length 784. Or you can just put a -1 here and say, hey, why don't you figure out, how to take this 2-dimensional data and convert it down to 1 dimension. It's not so hard, right? We did it. We figured out it was 784. And it turns out Pytorch can do the same thing for us. So by passing through this -1 here, okay, we'll call this my reshaped image. Right? By passing through the -1, we're saying, hey, I want this to now be just 1 dimension, and you figure out what it means to convert this 2-dimensional data down to 1 dimension. Just do the math, okay? What's kind of cool is that you can actually take all of the images. So remember, we had this X-tensor float, or I think it's just X-tensor.dtype. Let's make sure that's a type float, okay? And if we look at the shape, that's 60,000 by 28 by 28. What we want it to be is 60,000 vectors, right? 60,000, 60,000 observations. Each is a single dimensional vector of length 784. So what we can do is call view 60,000, 1, 2, 3, comma, -1. So we're saying reduce this down to 2 dimensions, and you do the math to figure this out. And I'm going to call this X-tensor reshaped. And I do that. And now let's confirm. Let's see what this is. So now if I do .shape of this reshaped thing, you see that? It converted it to 60,000 observations. Each one now is a single vector. We can further confirm that by maybe looking at the first one. So we're getting our first image. And now this is just a vector, a 1-dimensional vector of length 784. See that? It's all just 1 vector. So that's pretty good. I think that's essentially what we need, is this 1-dimensional vector, right? Because now we have 60,000 observations, each one's a vector, and we should be able to pass this list of vectors into our neural network. All right, so here's our neural network, right? We're going to take this thing. All right, this is our single observation, I guess, a vector of length 784, and pass that to our linear layer, which has a weight vector, has a 64 neurons, each of which has a weight vector of length 784. And then they're all going to, these 64 neurons are going to each apply the dot product. So we'll get 64 outputs in that bias term, but still 64 outputs. Then those 64 outputs are passed to the sigmoid function. Here we get 64 outputs between 0 and 1. And then we pass those 64 outputs into the next layer. Then this is going to give us a weight vector, 10 neurons, each with a weight vector of length 64. We apply the dot product effectively 10 times, and that gives us 10 different outputs for this soft map, right? Then we apply the soft max to give us that, hey, that probability essentially, right? That probability of an exaggerated prediction of which of these digits from 0 to 9 do we think the output is. Okay, so that's it, right? We've kind of reshaped our data. And what's next is pass it through our neural network. So we have defined our neural network. We have our reshaped data. Let's just make sure this is in fact reshaped. First image.shape. And I guess I did not. X-tensor reshaped is what I called that. There you go, single vector. Let's pass that single vector into our neural network. Let's see the output. There it is. okay? So we have just, coerced our data so that we could pass it through our neural network. And we just did the first image, but if you wanted to, you can pass through, 50 maybe at a time. Just hope this doesn't break, and we get 50 predictions. Okay, so for each one of our images, we're now getting, of these first 50 images, we're now getting a separate set of predictions. Now, we have not yet trained our neural network, so that we'll do in the next lesson. But what we have seen is, the steps to start with our data, download it from Keras. We took a look at it. We then converted it into a tensor. We then converted that tensor to make sure that it is a float. And then we said the dimensions are off, right? Because they're each of this grid of 28 by 28. And instead what we want to do is do this view, call this view function, to reshape the data. So that's just each observation is now one dimension, right? One vector of length 784. And that way we can pass that vector and do that vector matrix multiplication, right? To get back an output, right? Pass that data through that first linear layer. And we said the way that we can do that is that we can take our data, right? If this is 60,000 by 28 by 28, we can do dot view and say we still want 60,000 observations, but now you, Pytorch, figure out how to scope it down. And that'll be my X reshaped. And then if we look at the shape here, it's looking pretty good. And that's something that we can ultimately pass through the neural network, okay? Cool. So the next thing is we will move on towards going through this whole process of taking our data and building a neural network that trains on this data and makes predictions in Pytorch. So that is what's coming up next. See you guys in a little bit.